Hi and welcome to video 5 of Unit 1 Topic 1 from our Specialist Math curriculum. And in this video we're going to look at some examples of permutations in action and show you how you can simplify algebraically but how you can also apply them in context. So we're going to start with a simplified question, 7p3 without a calculator. So this could come up in a tech-free exam. Well, 7p3 is just 7 factorial over 7 minus 3 factorial, because we now know n factorial over n minus r factorial is our NPR notation. And so this is 7 factorial over 4 factorial. And I'm going to do this longhand, so I'll create a bit of space here. You don't have to take this long when you're working it out, but I'll write this down as 7 times 6 times 5 times 4 factorial over 4 factorial, and they cancel out, leaving us with 210. So 7p3 is equal to 210. Now simplifying n plus 1 p n minus 1, this will be equal to n plus 1 factorial over n plus 1 minus n minus 1 factorial. So this is n minus r. So that is n plus 1 factorial over, and now we get, on the bottom, we get n plus 1 minus n plus 1 factorial. And so this will be equal to n plus 1 factorial over 2 factorial, which of course, in simplest form, can be written as a half n plus 1 factorial. And that's about as simplified as we can go. You need to recognise that n plus 1 factorial with no knowledge of n really isn't going to lead anywhere. So let's have a look at example 3. How many ways can a 4-letter word be made from the letters in the word history? Note, the word does not need to make sense, i.e. RSTH is one of the options. So in this case, let's just look at this logically first. We want a 4-letter word, and so we can choose any one of those letters first, any one of those letters second, any one of those letters third, but notice here that once we take a letter, it's gone. So I'm working on that assumption, which actually isn't really well enunciated in the question, but usually when we're dealing with permutations, once a letter is gone or once an object is gone, it's gone. And there's 4 ways of choosing the last one. So this is the multiplicative principle from video 1 and 2. We multiply along each of these and we get 840 possible outcomes. But the other option, of course, is to consider this as a 7 pick 4. So we're going to pick 4 objects from the 7, which means that the answer could also be 7p4, which in this case is equal to 7 factorial over 3 factorial, which is just equal to 840. Same thing again, or you might have a calculator available and put it into your calculator. So there's some examples of unordered or unrestricted permutations. And keep in mind, of course, the theme that's coming through here, a permutation is a situation that arises where order doesn't matter. But we'll talk more about this. So there's example 3 finished, and it's our last example on unrestricted permutations. In our next video, we'll look at some situations where we have restrictions in place or constraints that make the question a little bit harder, but still very doable. All the best.